Hi guys, welcome back to another homework assignment, which I know makes you so excited, but this is homework 8.2, which is due on Thursday, 5:15. Oh, anyway, the first question we have to work with is um, basically using a percent to calculate the whole problem with one multiplication as opposed to the two steps that we have done previously. So, increasing, you need to remember, is 1 plus the percent. Okay? Later on when we do decreasing, I'll show you what that means. But if we're increasing 350 by 5%, what you need to do is first figure out the percentage by adding 1 plus 0.05 to give us 1.05. Okay? So we're going to do 350 times 1.05, which gives us 367.5. Okay? Practice again, increasing by 2%. We're going to add 1 to the 2%, giving us 1.02. And multiply that by the 34, and we end up getting 34.86. Now, the next one, increase $450 by 3.5%. So that's going to be 1.035. Be careful about the decimals, adding that extra zero there. So we have 450 times this, which gives us 465.75. Since it's money, we're going to put a little dollar sign in front. Okay? Now, decreasing a number is very similar, but it's going to be 1 minus the percent. Remember, if you're decreasing something, you have to be multiplying it by a number smaller than 1. So 6%, we're going to do 1 minus 0.06, which gives us 0.94. So we're going to do 450 times 0.94, which gives us 423. Decreasing 122,000 by 12%. Okay. So we're decreasing, we're going to do 1 minus 0.12, which gives us 0.88. So 122,000 times 0.88 is 107,360. Now remember, in both these cases, when we're doing decreasing, the number is getting smaller than the original. In the increases, they got bigger. Okay? Now, decrease this dollar amount by 3%, $1,820. We're going to do 1 minus 0.03 to start with. We get 0.97. So I'm going to do 1,820 times 0.97, and we get 1,765.40. Okay? And it's going to be a dollar amount. Now, we have to add the extra zero because we're dealing with money. Okay, so that's pretty much it with that. Now, just remember, decreasing makes the numbers smaller, increasing makes the numbers bigger. Now, Raina was given $5,000 when she was born. Her parents invested it at a 2.5 interest rate compounded annually. No deposits or withdrawals were made. Now, what we're going to be doing is first making the exponential equation that represents the situation. You need to remember, we have y equals a b to the x. Okay? A is the initial amount, and b is the growth. And since we're dealing with a percentage, and we're increasing that percentage, because that's what an interest does, we're going to be doing 1 plus 0.025, which gives us 1.025, and that's going to be our b value. That's going to be inside the parentheses. Now the initial amount is the $5,000. That will be our a. So all you got to do is plug it in. Y equals 5,000 times 1.025 raised to the t in this case, because we're dealing with the number of years. Sorry, I forgot to mention that. T is going to be our x in the problem. Okay? Now, how much money was in the account when Raina is 18? Now, on the quiz you'll get on this week, it is going to be a little bit more difficult because I'm going to make it so that she doesn't have, it may be a certain time that she was born. They did it when she was 2 or 3 years old. So in this case, t is going to be equal to 18. Okay. So what we need to do is we need to do 5,000 times by 1.025 raised to the 18th. Now if you put that into your calculator, you'll end up getting $7,798.29. Okay. Now, if Raina decides to keep the money in the account until she's 30, how much more money will be in the account than when she was 18? So, if we're doing 18, we already have the amount when she was 18, we need to figure out the time when she was 30. Okay. So it'll be 30 years after she was born, she's 30. So what we're going to do is plug it back in, so 5,000 times 1.025 raised to the 30th power. And when we do that, we get 10,487.84. Now, the key thing with this question is that they're asking how much more money she'll be getting. So what you need to do is take this value, subtract from the $7,798.29 we got in the first part, and solve it, and we'll get $2,689.55 difference. Okay? That's how much more money she'll get by waiting for 12 more years. Okay, now let's take a look at the oil spread. An oil spill is spreading such that its area is given by the exponential function a of t equals 250 times 1.15 to the t, where a is the area in square feet and t is the time as a lap in days. Now, what we're going to do is basically analyze the equation. You need to remember the equation we mentioned before, y equals a b raised to the x. A is the initial, b is the growth factor. So how large is the oil spill initially? That's basically asking what is A. Okay? And we're talking about the number that's right in front of the parentheses, in this case is 250. So we're going to do, so basically 250 square feet of oil. Okay. By what percent is the oil spill increasing each hour? Okay, and I'm probably going to change this today. I apologize. So, what percent is the oil increasing each day? What you need to do is look at, we have 1.15 is our growth factor, but remember, this is going to be with the percentage. So we need to subtract 1 from this, and we get 0.15. Just like in all the first problem, and the first problem we added the percent when we were doing an increase to 1. Now, because we're looking for the percent, you're going to subtract. Then we're going to convert 0.15 to a percentage by doing 15%. Okay? Now, how many days will it take the oil spill to increase to 3,000 square feet? Now, in this case, what we need to do is we're going to plug in. There's a lot of guess and check. If you have a TI-84 calculator, you can just put this into the y equals, and then just look at the table, find the value. And that's what I'll be expecting you to do, and that's what New York State will be expecting you to do. You could just sort of do some guessing and checking, but it is t equals 18. Okay? If you just plug in some values like t equals 15, you'll notice that it's only going to be about 2,000. Then you go 16, 17, 18. You can do it really quickly in your calculator. When you get to t equals 18, plug it into the equation. So we have 250 times 1.15 raised to the 18th power. It will be 3,093.86. Okay? Cool. Now let's take a look at the next page. The amount of A in grams of radioactive material that's decaying can be modeled by ohms. Once again, I'm giving you the equation that you need to use. Okay? So what we need to do from here is look at the situation we have. So what is the initial amount of radioactive material? So remember, once again, y equals A is b to the x. Okay? Match it up. A is the initial amount. So take a look here. I got 450 in the front. So it's going to be 450 grams of the radioactive material. Now, what percentage of the material is decaying? Just like in the first problem when we had to do, when I gave you the percent that we're decreasing it by, you're going to do 1 minus. We did 1 minus the percentage, so what we need to do is you take 0.88, which is the B value here, and we're going to do 1 minus the 0.88 to get the percentage. You get 0.12, which as a percent is 12%. Now, how much material is left after 30 days? I'm just asking you to find out how much material is left. So what we need to do is just plug it in, so 450 times 0.88 raised to the 30th power. And when you put that into your calculator, you will get 9.72 grams. So just 1 month after the material, we had 450 grams at the beginning. So I should change that to an ounce. Okay. Now we have 9.72 grams left. Now, this is the type of question that comes up sometimes on the Regents exam, and I will definitely be asking 1 or 2 of these on your quiz and test. For each of the following problems of table values, first determine if the table represents a linear function in the form of y equals mx plus b, or an exponential function in the form of y equals a raised to the b, a times b raised to the s. Then write its equation. Here's the key thing with this, guys. You need to remember something. The linear function or a linear equation basically means we're going to be adding at a constant rate. And that'll give us our slope. The exponential function, on the other hand, that will be multiplying at a constant rate. And this is the key difference between the two. So what you need to do, I just like to just sort of play guess and check. One thing to mention before we begin with this is notice that all these are increasing by 1. If there was a different increase, you would have to approach the problem differently and actually find the slope. Or at least make sure that if it was 1 to 3 and they didn't have this 2 here, that you were dividing the amount that you're adding by 2 and make sure that they're all the same. So if we take a look here, let's go from 4 to 7. That's really I'm adding 3. So I'm going from 7 to 10, I'm adding 3. If you start noticing, I'm adding 3 to every single one of these. Okay? This basically means our slope is going to be 3. Because it is constant for everything, it is going to be a linear function. So what we need to do from here is we need to solve the equation. Y equals mx plus b is our equation. From here, what should we do? We know the slope, we already determined with 3. Now to figure out the initial value, look at when x equals 0. The y value is going to be our y-intercept, which is 7. Okay. Now, let's take a look at the next one. This becomes a little trickier. How do I get from 2 to 6? I add 4. Now, check to see if it works. 6 plus 4 gives us, oh no, it's actually going to be 12 here. Notice, we're not adding by a constant rate, so it's not going to be adding. I can cross that right off. Now, let's check. 2 times what will give me 6? 3. 6 times 3 give me 18. Oh, look at that. It keeps working. Okay. Everything is being multiplied by 3. I'm still going in constant order, so 0, 1, 2, 3, 4. So we know it's going to be an exponential equation. And in this case, an exponential equation, this is going to be our b value. This is going to be our growth rate. But let's first remember the equation y equals a times b to the x. So what we need to do from here is we need to look at the a value, which is the initial. In this case, it would be 2. So y equals 2. In parentheses is going to be the number that we're multiplying by, which is 3, raised to the x power. Okay? Now, take a look at the next one. All my x values are going up by 1, so we're good. Now, to get from 32 to 16, I would have to subtract 16. But to get from 16 to 8, I would have to subtract 8. And look, they're not the same. So that means it's going to be an exponential equation, but let's just double check that. What times 32 will give me 16? Now, in your head, you're probably going, oh, if I divide 32 by 2, I'll get 16, but I'm not asking about dividing. I'm asking about multiplying. So if I'm asking about multiplying, remember, if you're dividing by 2, it's the same thing as multiplying by 1/2. Okay? Same thing here. Should I multiply 16 by 1/2 to get 8? The answer would be yes. This one, I'm going to multiply by 1/2. Oh, look at that. We get the perfect amount, multiplying by the same amount each time, so it's going to be an exponential equation. Now from here, what we can do is we're going from 32 to 16. We're going to find the equation now. So y equals a times b to the x. Okay. Now, what's the initial value? It's going to be 8. So y equals 8. B, the b value is going to be the number that we're multiplying by, which is 1/2 in this case. That's raised to the x. Okay. Now let's take a look at the next one. We have 32 to 16. I'm checking with the adding first because that's usually the easiest. 16 minus 16 will give me 0. 0 minus 16 gives me negative 16, and then negative 16 minus 16 gives me 32. Negative 32. So we know it's going to be a linear equation because we are adding, or in this case subtracting, by the same number over and over. So this is going to be our slope. Okay? So we know we're going to use y equals mx plus b. Our slope is going to be negative 16, so y equals negative 16x. And b is going to be our initial value, which is 0 in this case. We don't even need to put it, so plus 0 just goes away. Okay, now the last problem, before we can be like, yay, we're done with this homework, is we're going to subtract, see what the difference is. 180 to 160 is, we're going to subtract 20. We subtract 20 here. Oh, look at that. We're subtracting by 20 in every single case. Okay? So we know it is going to be a linear function. So let's write down linear. Now y equals mx plus b. Again. Okay? The slope is going to be negative 20. So y equals negative 20. Our y-intercept is going to be our, our initial value is going to be 180. And we are done. Okay. Now, just to keep in mind, you are going to get questions just like this on your quiz, so make sure you understand how to do any of these. If you want, you can always email me. My email is adunbar@southcountry.org, or you can just ask questions in class. Anyway, have a good night, or a good day, whenever you're watching this. Probably really late at night, the day before this is due. Okay, have a good night. Bye.